Hello everyone, my name is Cherie Ledoux and I'd like to welcome you to today's webinar, Vulcan Scripting. Your host today is Nate Bazar. Nate is a mining engineer too on the Mine Solutions team and provides consulting and training services in the North American region. He has written a number of scripts for clients and will teach the upcoming course, Introduction to Lava Scripts, to be held later this year in both Denver and Elko. A few things before we get started. First, today's webinar will conclude with a question and answer session, so please feel free to write questions in the panel on the right-hand side of your screen. Also, you will receive a link to a recording of this webinar by email in case you'd like to see it again. It will also be available on the Maptek website at a later date. I'll now hand it over to Nate.
Morning, everybody. So today we're going to look into a little bit of Vulcan scripting. Now, Vulcan scripting is a bit of a large topic, so we're going to try and look at a few areas for scripting to kind of cover the range of what's available. So on the simple side, we're going to look at things like automating processes with macros, so areas where we can simplify long workflows, automate repetitive tasks, such as tools like rotating triangulations or even creating triangulations that require you to do a lot of manual input. We'll look at a couple of options of how to automate those. We'll also look at a couple examples that come out of the classroom training for the Introduction to Lava course, such as creating envisage data or block model inquire. And then we'll also look at some more advanced Maptek scripts, showing kind of how far-reaching scripts actually let us go. So with that, we'll actually move right into the demo. So here in Vulcan, like I said, we're going to start in the macros side of things. I've got these triangulations that I want to rotate 30 degrees, and if I do that manually, it becomes a very tedious process. So as a quick example here, I have a couple of individual stopes just to work with. If I want to move these, I use the model triangle utility rotate function. I pick a center of rotation. I tell it how I want to rotate, so in this case 30 degrees, about the z-axis. I'm going to rotate my original, I pick it, and it's going to do the rotation. The problem with that is it's very tedious if I want to click on every single one of these. I don't want to have to do that much work, so we can use macros to save us a lot of work. In the case of the stopes I had loaded earlier, I actually had 272 shapes in there. I don't really want to click 272 times. So if we want to turn this into a bit more of an automated process, we can record our functions using the file macro create option. This will record any Vulcan functions. So here we're going to call this rotate macro, recording our rotation. And then that'll bring up our macro control panel. Now, we have a few options on this panel where we can abort, cancel, interactive, or ignore on a macro mismatch. What that means is, what is it going to do in the case that something's wrong? Say this triangulation that I use doesn't exist anymore, or the data type isn't quite right, something of that nature. Abort will tell it just to stop the entire script. Something is wrong, I can't go on. Cancel says, I'm just going to cancel the function and try to continue from there. Interactive will actually go to the user and say, hey, something's wrong. Give me some input on how I can actually fix whatever went wrong. And ignore just says, we'll keep going and not worry about that problem. Now, since we're building this into a little bit smarter tool, I'm going to abort. So all I have to do is perform the function, Vulcan, and record it. So if I go back to my triangle utility rotate, you can see it keeps changing what it will record. So an absolute point being whatever I click, or interactive. But I'm going to go with absolute. So again, I'm just going to record my option, telling it again, use my values. Rotate, and I pick a shape to rotate. Once I'm done, I can just right-click and then stop the recording of my macro. What that does is actually creates a little lava script for me that is the triangle utility rotate around a certain point with the angle and whatever shape I've asked it for. Now, right now, that's actually a very, very bad little macro, because all it does for me is if I run it, it will rotate the same shape over and over and over. It doesn't actually give me the option. It's just going to keep rotating that same shape. So to make that a little bit smarter, I've got this script here that I've put together where we create a panel that asks the user for a selection file. So instead of saying just run on one triangulation, we actually can feed it a selection file which will give it a full list of any triangulations I want it to operate on. And then a component on our panel to ask for the rotation angle, so how far we want it to rotate. Now, in here, we have some standard Perl code saying open my file and then read each line. If it's not a triangulation, we're going to skip it. And we're going to add each line to this array called contents. So it'll allow us to go through all of our different triangulations and perform some action on it. Now, all of this stuff is standard Perl. So when you hear Lava versus Perl, it's actually the same language. The only difference being Lava is when we actually are using Vulcan-specific functionality. So things like a Vulcan panel or running Vulcan tools like those macros. So here, after I've read that selection file, I can come through, loop through all of my different triangulations in the file, and run my rotate macro function. Now that rotate macro function down here is empty. That's where we're actually going to use that macro we recorded. So I've run some standard Perl to allow me to run through multiple triangulations, and all I have to do to make it useful in Vulcan is just bring in this macro. So I can copy it over and I'll paste it into that function there. And then I have to do a little bit of quick customization to tell it what triangulation and what angle to use. So angle of rotation here, I can see I've got -30, so I'll change it to my angle variable. And then my triangulation down here, I'll change to my triangulation variable. Now you can get much, much more creative with these. I've gone very simple for the sake of this webinar, but you could customize the center points to be the centroid of each shape, all sorts of other things like that to allow you to manipulate your data however you need to. But for this simple case, this will be enough. So now it knows what the angle is and what shape to rotate. So I'll go ahead and close my script there. We'll do a quick test on these. I'll highlight my couple of test files here, create a selection file out of those. We'll call it test. And now I can run my script. I'll pick my test selection file, my -30-degree rotation angle, and all three of them are rotated for me. So now I've got a script that on any selection file I give it will rotate any number of stopes. So I've got all of these roughly 300 stopes. I can pick my selection file, -30 for my rotation angle, I hit OK, and then Vulcan reads through the file and moves all of them automatically for me without any additional input on my end. All it takes is making a selection file and using that script. Pretty quick and easy. So another example of using macros is in a case where we're triangulating data. So here I've got an ore body from our intro training courses. And it's a very straightforward ore body on each end. So down here it's pretty straightforward, and over here it's pretty straightforward. It's got a split in the middle where it'll actually split off between the two sides. This is the only area I personally want to work on or put any concern to. Now, I've got an ore body in this case, but you could also have, say, different mining sections. So this could be one area of stopes, and over here could be another area of continuous shapes for another set of stopes that, as you design them, maybe use features or grouping to indicate when there's a change in area. What I've done is on these I've put a group, so it will detect when the group changes and triangulate each group independently. So this script here, I'm using my triangle solid create function that I've recorded as a macro and again put into a small little subroutine within Perl. I read my data off of the screen and I ask for the layer and the group of each item. Now I've gone with layer and group because that works for this data, but again if you're using say features or some other criteria to identify the different items that you might have, you can add a few more. And then all I do is combine each one using the layer with 2 dashes in the middle, and then I add the group. And then I take each of those and add them to a hash table in Perl. Now, I'm not going to discuss hash tables here. That's just standard Perl functionality, but it's basically a list. In the case of a hash table, they're unique and they won't allow duplication. So I can add any of them, and if it sees the same thing twice, it won't accidentally add it twice. And then all I do is I go through and loop all of the data in my runs that I've given it and pass those to my triangulate subroutine. So this triangulate subroutine pulls in the run, it splits back out based on those double dashes, my layer and my group, and I can create a triangulation picking all of the stuff in one layer and in a particular group. And then I've got the name here set as run, so it uses the layer dash dash group as the name of the triangulation that it generates. But it's very, very simple. I've only had to change 3 things here against my macro, and it's able to know when to change and move through them. So I run my triangulate script. I can select all of my data, and it'll automatically triangulate each piece individually. Now, in this little scenario, that seems like a lot more work than what it would take just to do it manually. But you want to think about the cases where scripting can really come into play and save you a lot of energy. So in areas where you have a lot of data. So if I get rid of all these, I have a scenario here, very much the same, just duplicated of that ore body shape. But again, this could be stopes or anything else. So if you're doing manual designs of stopes, as long as you keep a unique group or some form of identifier for each individual stope, even the name, whatever else it might be, then you can customize using something like the script I put together to be able to automatically move through each one and triangulate them all on their own. So here's a whole bunch of them that I've got. Same script, no changes required. I just tell it to pick all of the data, and it will go and find each individual unique piece and triangulate them all. So if you have 1,000 stopes, then this becomes very, very advantageous and saves you a lot of time. Now, on my initial case, not so much, but something like this, it becomes very, very nice. So macros are our easiest way to use Vulcan functionality with a little bit of Perl scripting to save ourselves a lot of work, get rid of those repetitive tasks or the things that we do on a regular basis. We have a couple of inputs, and then we let it go through and do all of the other pieces for us using standard Vulcan functionality by recording them using the file macro create function. Now, if we want to get a little bit more fancy, we can actually start using some of the other built-in tools in the Perl modules. So let me go ahead and get rid of these triangulations just to clean up my working directory. So I have this one here that was written to determine the minimums and maximums of triangulation. So basically it exports your vertex statistics of a triangulation out to a CSV. So then maybe if you want to know the heights of a stope or the minimum elevations, any of those sorts of things to put into, say, naming convention or any of that, that's where this sort of script could come into play. So it should look oddly familiar for this first portion here. We actually copied all of the data from my first script to create the panel. The only difference is instead of asking for an angle, we're asking for the name of the CSV output file. We read our file, our selection file, excuse me, check to make sure they're triangulations, otherwise we'll skip them, and we build a list of all the triangulations that we wanted to analyze. Now that I've got my list from this portion here, I come down, I'm going to open up my output file and print the header line to my output file. And then I'm going to go loop through all of my triangulations. I'm going to open them using the Vulcan triangulation class. And then I'm going to determine how many nodes it has and get all of the coordinates for each node. And then I'll actually just check to see, have I found the minimum or the maximum for my XYZ and then the maximum for the XYZ. Once I've found the max and I've looped through all the points, I know the correct numbers, I'll then print out the triangulation name and then all of its details. And I just continue to loop through all of the triangulations. So it's really, really simple little script, again, duplicating what I had in my first script over here. So if we look at that one, go ahead and run it. I already have my selection file set up. So I'll just call this min-max, and I'll hit OK. And you can see process 272 triangulations, and it output the vertex data. So if I open up my working directory here and sort by my date modified, my first file on the list is my min-max. So I open up this CSV, and I now have all of my stope names with its vertex statistics for minimum and maximum values. Looks like I had a copy-paste error in there a while back. Looks my Z minimum and Y minimum have been switched with each other, but that's an easy enough fix. So it looks like I just printed this one in the wrong spot. So we'll move this one over really quick. And there we go. Now that script is fixed. We'll rerun it, repick our selection, make sure our Excel file is closed, and then we can run it again. There we go. So now I've got my triangulation name, minimum, maximum for my X and Y, minimum, maximum for the Z values as well. And then all we have to do, if we want to say build a naming convention, we can do the stuff that we're all very familiar with to play around with our Excel numbers and naming in there. Now another one that I had that came in, actually I see the guy who's I'm building it for in the webinar today. We built a tool to build the end drift face for face mapping, essentially. So in here, you pick a center line, and in a matter of seconds, it'll come through and it'll build a triangle, or excuse me, not a triangle, a rectangle at each face, so then you could build triangulations off these, do iregs across them, and be able to do some face mapping with them. It's actually a very, very simple script for this component here. All I have to do is read in my center line. I determine what my last point is on the line. I figure out the bearing between the last 2 points to know where my line's going. And then I do some work to build the faces at the various angles using some of these tools, such as the lava object modules and classes within Vulcan, and that allows us to create envisaged data. So on our min-max script over here, we use the triangulation classes to be able to work with triangulation data, and actually in that you can also build triangulations. And in here we have some tools for building objects. And there's also classes as well for accessing block models and design databases, depending on how far you want to go. So that's a pretty wide range so far that we've covered of what you can do with Vulcan scripting, depending on the level of complexity. Now, we can take some of these tools, like we've seen in the min-max and build drift faces, and actually go even more complex and look at something like what our developers can put together. So this is a script that we put together for a client who's been nice enough to let us show it, where essentially what they wanted to do is take a plane surface that represents the contact of the hanging wall of their deposit, and they wanted to figure out and kind of get essentially a heat map of grade for some thickness normal to the hanging wall. Currently in Vulcan, you don't really have the functionality for that. You would have to basically create a box, and then you could get an average grade of that entire surface, but you couldn't get it across the deposit at any spacing that you requested. So we ended up working on putting the script together for them that actually will do it. So we give it the plane, the block model, density, legends to use, big variables that we want to contour, and then it actually will create a grid spacing, in this case of 60 feet. Every 60 foot it'll create a point, and then it'll calculate the grade at 20 feet above the hanging wall and 120 foot below, representing a 25-foot radius around each of those points. And then it also has some information for calculating the average plane to determine how to make it normal to the hanging wall. So if I go ahead and run this script here, you can see it's going through and processing some of the data, and it gives us a series of grid points that now are colored based on the grade with the legend that I gave it. And actually each individual point, I'm going to go ahead and hide my surface, is actually labeled with the W tag representing the grade at each point. So to see a little bit better of how this works out, I've had it also output the triangulations it uses to demonstrate what it's doing. Where here we have the grid plane to determine the general plane of the entire ore body. And then you can see each individual cylinder it used for calculating the grade of that deposit as it moves throughout it. And they're all normal to each individual section. Excuse me, I can't talk today. Now, this isn't a very good representation because it's so widely spaced. So what I've actually done is I've run it before with a little bit tighter spacing. It just takes a few more minutes to run. And you'll see here we have a much better representation of what the grade looks like as it moves across the deposit. And what we can do is actually triangulate this data using the W tag as the Z value. And we can get a grade surface, essentially. That represents the grade across the deposit. So all of this out here is minus 99 or no grade. And then in here you can actually see the variability of grade moving through the deposit. All I have to do with that is I can then color my surface by axis using the other surface, and then that'll actually turn it into a heat map of grade across the deposit. The reason they were doing this is so then they can try and figure out better where to place mineable units. So if they had, say, a geotechnical constraint in an area where they can only have one mineable zone in here, you can see in this case the lower area is lower grade, so we'd probably want to push it up higher, and especially say here where it goes bright white, we know that's a really good high grade pocket that we'd want to chase after. So this one is essentially to the capacity of, say, a Vulcan option. You can see we've got a really nice large panel that gave them even the ability for doing batch runs, all sorts of crazy things. So Vulcan scripting really runs a very wide range. I hit on some of the ones that are easy to do today, such as the macros, but then kind of progressing through all of the even crazier cases like this one. So on that, we'll do a little recap here. But macros, they're really good for recording simple tools and kind of creating a repetition process there. They're very, very easy to build and record because Vulcan does all of the recording part for you. And then as long as you can go through and kind of try and do a little bit of evaluation as to what parts do what, you can then modify it with a little bit of Perl knowledge to do whatever you need. But then if you want to get a little bit more advanced into the custom scripting, I know I very lightly touched on these topics, but we actually have our Introduction to JavaScript classes coming up in June in Denver and then in July in Elko. Actually, I'll be teaching those courses. Those actually cover all of the different tools such as triangulations, block models, design databases, and even ISIS databases, where we'll go through different cases of how to create scripts that utilize those functions and how to build them robust. And then if it just seems like it's too much work or you don't have the time, we also do offer our consulting services for scripts where we get our developers to come in and they will put together the scripts for you. The one nice thing about those is they also include maintenance for any future versions. So if something changes in Vulcan, say you downloaded Vulcan 10 today, or yesterday, excuse me, and it doesn't work. Your script broke between Vulcan 9 and Vulcan 10 for whatever reason. Maybe we've changed a function or some sort of functionality no longer exists maybe. With the scripts that we put together, we actually include maintenance in the price of the script. So if it ever breaks, you call us up, say, hey, my script doesn't work in Vulcan 10. We'll go through, we'll figure out what's wrong, we'll fix it, and then ship you a new version. So it'll always work for any future versions of Vulcan. So on that, any questions? And I'll hand it over to Tree.
Great. Thank you, Nate. That was great. As I mentioned before, the panel on the right-hand side of your screen, you can go ahead and ask questions through there. It looks like we do have a couple so far already, Nate. The first one I have here is, what level of Perl is recommended to start scripting in Vulcan Lava?
So as far as the level of Perl knowledge, truthfully, you can kind of start learning off the internet for some of the basic macro type functions and do things like how do I go through a list of files, those sorts of things. And pretty minimal knowledge is really needed there. You can learn a lot of what you need just by searching it on the internet, truthfully. But if you do take something like our Introduction to Lava course, we actually spend one day covering the essentials of Perl to get you going and actually say, here's what you need for Perl. And then on the second 2 days of that course, then we get into the actual Vulcan functionality, but we make sure that by the time you leave that course, you have both the Perl and the Vulcan knowledge to be able to write any of the scripts that you need to.
Do you have examples of scripts working with a drill hole database?
We actually do go through a few of those, say in the Introduction to Lava course. There's classes set aside for how to access drill hole databases, composite databases, actually any form of ISIS databases are accessible through the Vulcan modules. I don't think I have anything that I can make accessible after this presentation, but definitely if you take our Introduction to Lava, we do get several examples in that course.
Okay. Can you make the demo scripts that you use today available to participants?
I can. I can only make the first couple of scripts there available, especially that very last one, the visualizer script, because that was a paid script for another client. That one won't go out, but they will be made available on the Maptek website in the users area in the Vulcan, excuse me, the webinar Vulcan scripting group, and they'll be accessible from there.
Okay. How do you create the build panel part of the script?
So the portions for panels are pretty simple. So actually, let me go ahead and pop up my editor here. So in the Vulcan tools, you can use the new Lava panel, and then you just add each of the items that you want into it. The minimum requirements for a panel is this right here. So my Lava panel is a new Lava panel. You have to have something added to your panel, regardless of what it is. Something has to be added in the middle there. And then you have to have this execute function to say it actually brings it up on the screen. But the Vulcan help actually has very good documentation under the Lava class of how to get into some of the panel functionality. If I can get in there 1 second. Go right here. So under the envisage file Lava, you actually have the list of classes and all the details in here, and you can see we have the Lava panel class, and that details out any of the functionality available, and actually gives a few examples of how to generate some panels as well.
Okay. It looks like we're nearing the end of our time today. If you have additional questions after the webinar, please post them in the users area on our website. If you're not a Maptek client and don't have access to the users area, simply email solutions@maptek.com and we'll ensure your questions are answered. As Nate mentioned, he is going to make these scripts available to you in the users area. There has been a group developed that is called Webinar Vulcan Scripting. So simply go there and you can find the scripts that he's placed for you. He'll probably put those in, I would think, later today. So on behalf of the entire Maptek team, I'd like to thank you for attending today. Please visit maptek.com/webinars for a complete list of upcoming and recorded webinars. Thank you and have a great day.